Hey everyone, Terry Vincent here with IPExpert, welcoming you to our conversation about our next interior gateway routing protocol, and that's going to be EIGRP, Enhanced Interior Gateway Routing Protocol. Now what we're going to do is we're going to work with EIGRP in the context of the deployment that you see here. What we have in this particular scenario is a series of a main office attached to 3 remote sites through the use of a DMVPN, and we also have an off-site data center that we're actually simulating using another device. This is the same deployment that we used in our discussions about our RIP version 2, our RIP-NG conversations, and we're going to use this exact same deployment to discuss the configurational requirements, the operational capabilities, and parameters used by EIGRP, both for IPv4 and for IPv6. So let's take a look at exactly what's going on, because what we want to do at this point is entertain the idea of how we create neighbor relationships. A neighbor relationship is going to be a scenario or a situation whereby 2 EIGRP speakers are going to be configured such that they can discover other neighbors on their segment. They're going to do this on the basis of a multicast address exchange. So we're going to exchange multicast hello messages. Now what I want to do is I want to spend the next little bit interviewing or entertaining this process. So what I'm going to do is I'm going to bring up a set of links, and then what we're going to do is we're going to do some diagnostics. Yes, you heard it here, diagnostics on how we're going to be able to monitor this process. We'll do it first on the command line, and then I'm going to try to see if I can't get some Wireshark traces for us to take a look at. So diving into this, what we're going to do is we're going to create an EIGRP environment. We're going to say EIGRP Autonomous System 10, and I'm going to run every interface and every loopback 0 on all of the devices in our topology, to include R22, R2, R3, Cat 1 and 2, R1, 4, 5, and my remote sites. So as you can see, we've got quite a bit of configuration that we're going to need to do here in order to make this operational, but it won't take long. And I'm going to use my first recommendation, and that is that we're going to use the idea of wildcard masks to be able to selectively pick the prefixes that we want to participate in EIGRP. Now, I'm saying this because I want to recommend to everyone that's studying for the CCIE Routing and Switching version 5 exam that you advertise every prefix or every network that you want to be participating in a routing protocol using the most specific command syntax as possible. So let's take a look at this. So what we're going to do is, first of all, we're going to start on R22. So on R22, I'm going to type show IP alias. Now that's going to give me a list of the IP addresses currently configured. Now looking at this, I know this is R2's connection to R2. I'm sorry, this is R22's connection to R2. This is R22's connection to 3. So it's 22 connected to 2, 22 connected to 3, and we know that 172.116.222.222 is my loopback address. So what I'm going to do is I'm going to engage EIGRP, config T, router, EIGRP, and I said that we were going to use Autonomous System 10. Now what we'll do is I'm going to advertise these networks. I'm going to say advertise network 10.1.222.222, and I want to match it exactly. I'm going to say network 10.1.223.222, match it exactly. And then lastly, I want to advertise my loopback. Network 172.16.222.222, match exactly. Actually, this should be no, for some reason I thought it was just 22.22. All right, so now what we have is we have EIGRP enabled on this device. Now, what did this syntax do? Just like it did in RIP, we configured a network statement. The network statement allows me to be able to select prefixes that I want to advertise. But really and truly what the network statement does is it allows me to select interfaces that are going to run my routing protocol, whichever routing protocol that it is I'm actually using. Here I'm using EIGRP, obviously. So when we look at this, what's happening here is the system is going to say any interface that has an IP address that matches what I've defined in my network statement, I want it to participate in EIGRP. And I want it to advertise the mask that's configured on that interface. Let's take a look at this. So what I'm going to do is I'm going to type do show IP protocols. And what we're going to see here is we're going to see the details for EIGRP Autonomous System 10 running on my device. Now what I see here is I see a series of K values we're going to talk about, and I see a router ID, which is going to be the IP address of the highest configured loopback address on my device. I'm going to see a topology value here, which we'll talk about later on. But of these things, the points that I want to make is notice I have administrative distances. For internal prefixes, I have 90, and for external prefixes, I have 170. I'm going to load share across 4 paths by default, and EIGRP even has a value like RIP called the hop count. And notice a hop count greater than 100 is going to be treated as being infinite by our routing protocol. And also, we're going to entertain the fact that EIGRP has the capability of doing load sharing, but not necessarily load sharing across equal cost paths, but it can do load sharing against unequal cost paths in our infrastructure. And again, we'll entertain that on a case-by-case basis as we go through. Now, unlike the original version of EIGRP that we used in the Routing and Switching version 4 exam, which was the 12.4T code, in the 12.4T code, auto-summarization was on by default. This has been changed in 15 code. No longer will we have to go in and say no auto-summarization, which makes much more sense when you consider that EIGRP was a protocol that was meant to work in a modern infrastructure. I mean, nowadays, who would ever want to have auto-summarization taking place in their infrastructure on a address by address or a link by link boundary? That's something that we definitely don't want to have happen in our infrastructure, and now it's not something that we have to worry about it. Now, you will find me, simply because I've been doing this for a long time, I have a tendency of going ahead and just typing no summary, again, as a direct result of the fact that I've just been doing it for so long, and a lot of the environments that I work in today still are not running 15 code. So it's carryover. It's one of those things where, yes, it will take time to be able to do it, but what if somebody were actually to have gone in and turned that off, and then when I'm reapplying it? Because remember, in the context of the Routing and Switching version 5 exam, we're going to have pre-configuration, what I lovingly refer to as misconfiguration. So looking at how this is going to be integrated, we need to step closer. And notice, the maximum paths here was going to be for 4 for load sharing, and it's going to give me a listing of the interfaces that I'm routing for. So I'm actually routing for 10.1.222.222/32, 10.1.223.222/32, and 172.16.222.222/32. Now this confuses students a lot. This /32. All this is saying is that this is going to be how I configured my mask. I said match 1 or 10.1.222.222, and then I used 0.0.0.0 to check it. So in other words, what's happening is the system is going to say, well, the interface must have 10, must have 1, must have 222, must have 222, or it's not going to be participating in EIGRP. Again, I made it as strict and as granular as humanly possible, and I did that through the use of these /32 prefixes. But what you need to understand is that once this process goes through and matches, yes, we're going to say, okay, interface, in this instance, serial 2.1 and serial 2.0, and the loopback are going to be participating in the EIGRP. However, what prefix are they going to be advertising? Well, let's take a look at that. What we want to do is I'll go ahead and erase this scroll here. Let's take a look at how it's going to work. Well, the system says, okay, interface serial 2/0 is going to be running EIGRP. But what prefix do I advertise? Do show IP interface serial 2/0. What it's going to do is it's going to look at the system, going to look at the address, and it's going to advertise this network. So it's going to advertise 10.1.222.0/24 because of this being the mask that's actually configured on the physical interface itself. Now, to illustrate this point, all I'm going to do is I'm going to go up to R2 and we're going to do the matching configuration. First, what I'm going to do is I'm going to say router EIGRP 10 network, and I want to advertise my loopback. Well, let's get a listing of the interfaces that we have here. So do show IP alias. Well, I've got a number of them. I've got 10.1.23.2, I've got 10.1.2.10.2, I've got 10.1.222.2. So what we're going to do is I'm going to advertise my loopback, which I know is this prefix. So we'll say network, paste it in, match it exactly. Then what I'm going to do is I'm going to say network 10.1.222.2, which is going to be the interface that's pointing down to R22. So the moment I do this, 0, 0, 0, and I hit enter, I should form an adjacency, which we see. I'll take myself out of the equation here. We formed an adjacency with our neighbor, and that neighbor is 10.1.22.222 via serial 2/0, and it tells me that my adjacency is up. Now let's look at the contents of my routing table here. If I type show IP route EIGRP, what I'm going to see is that I am learning about this loopback. And notice this loopback is a 172, which tells me it's going to be, would normally be a Class B address, but I'm learning about networks that are actually being advertised as /24. So all I wanted to do is I wanted to point out the fact that even though we saw /32 for the networks advertised in the show IP protocols output, that's simply because I matched it exactly. If I'd have used a /24 like a 0.0.0 like 255, then what would end up happening is that there would have been a /24 in that output. That output has absolutely nothing to do with the prefixes that are being advertised. Now, what I want to do now is I want to take a look at what's going on across this interface. So I'm going to come into here and I'm going to say interface serial 2/0, and I'm going to shut it down. That's going to break my link and bring down my peering relationship that I have with my neighbor, which we can see right here. So now what I'm going to do is I'm going to do a debug. I'm going to say debug IP packet, and let's see, how do I want to do this? Just in case, config T, enable password, we'll say IPExpert, line console 0, logging, or log in, actually password, IPExpert, log in. All right, that gives me the capability of being able to connect. Actually, I need to do my line VTY, sorry. So I don't want to do a password here, so no login. No password here. Line VTY 0 to 4. We'll say password IPExpert, log in. So now before this happens, all I'm going to do is I'm going to say telnet to my local host. Let's see, telnet to 172.16.222.222. Unreachable, gateway down. Oh, I'm telnetting to the wrong device. So I need to go to 116.2.2. Refused by host. Show IP interface brief. Pipe E assigned. Let's see here. Telnet 172.16.2.2. Show run section VTY. Transport input none. Line VTY 0 to 4, transport, input, telnet, and SSH. There we go. IPExpert. EN IPExpert. There we go. So we're logged in. All right, so that's going to allow me to be able to connect to this if I break it. So IPExpert. So now what we want to do is we're going to do that debug. So I'm going to say debug IP packet detail. I'm going to hit enter. I'm going to say UL. Not yet, I won't. Interface or config T, interface serial 20, no shut. Do you all. Now let's see what happens. Interface should come up, and then what should happen is we should form an adjacency. Let's just wait for it. All right, I'm going to go ahead and turn the debug off. Now what I want to do is I'm going to scroll up to where we first started this. And I want to take a look at what we see going on here. So what we see here is we have packets that are being sourced from 10.1.222.2, which is my local interface, that are going to multicast address 224.0.0.10. So these hello messages, like I said, are being multicast, and that is going to be the link local multicast address that they're going to use by default. Now in RIP, when we did our configuration with RIP, we saw that we had UDP ports 520 or 521, depending on whether or not we were running IP version 2 or we were running the idea of our RIP-NG. In the confines of EIGRP, what we have to understand is EIGRP has its own transport protocol. Its transport protocol is going to be IP protocol 88. Here it is, right here. It's using protocol 88. Now, that is meant to imply that it has its own transport mechanism that is built into it. So when we use security configurations, we have to be very careful that we don't inadvertently stop the transit of IP88 traffic. So if we're going to be blocking traffic, it's important for us to remember that we need to allow the traffic that's going to be used to create these neighbor relationships. So very quickly, what I want to do is I'm going to go through my entire topology, and I'm going to enable the interfaces necessary to bring up a full configuration like we had when we were using our RIP config. We'll just verify this step by step as we go through the topology. So what I'll do is I'm going to, first of all, erase this screen output here. And we will take a highlighter and we'll mark the interfaces that we have configured thus far. Well, let's see. We've got R2 and we have R3 in the picture. So let's verify and see exactly what we've got running. So when it comes to R22, I've only got one adjacency. Do show IP EIGRP neighbors. Now notice I only have one adjacency. I know it's with R2. And the thing that I really want to call everyone's attention to right now is the fact that whenever we have a peering, we want to make certain that the queue count for that peering is going to be 0. Anything other than 0 indicates that we have a problem. Now what I want to do is I want to make certain that I can bring up my other connections. So I'm going to duck over to R3 and I'm going to say do show CDP neighbors. I just want to discover my interfaces. I'm connected to R22 via serial 21. So let's go ahead and see what the IP address there is. So do show IP interface brief. Pipe exclude assigned. So serial 20 or 21, excuse me, has this IP address on it. So router EIGRP 10 network, and I'm going to go ahead and plug that in, and again I'm going to match it exactly using my wildcard mask. So hopefully I should get a neighbor relationship, which I do almost instantly. Well, let's advertise our loopback. So network 172.16.3.3, match it exactly. Now, what we want to do is we want to make certain that we are going to be running a connection across the link connecting R2 to R3. That's going to be VLAN 23 for our purposes. And what I want to do is just identify which device I'm going to be connected to when it comes to going to R3 via VLAN 23. Well, I see this is 2.3, so that tells me it's VLAN 23. So this configuration is going to be on Ethernet 0.2. So again, network 10.1.23 3.0.0.0.0. And let's go over to R2 and do the same config. Router, EIGRP 10, network 10.1.23.2. Match exactly. And almost instantly, we would expect to see a peering relationship come up, which we do. As you can see right here behind me, it says that the new adjacency has been formed. So with that being done, now we're almost there. I'm just going to go ahead and do the rest of the configs. So what I need to do now is I need to go to cat 1, and we'll just wrap it all the way over to R1. So in this scenario, let's go ahead and do the rest of our configs. So do show IP interface brief, exclude assigned addresses, and I'm going to go ahead and run all of these in my protocol. So I'm going to say router EIGRP 10. I'm going to say network 172.16.111.111. Match it exactly. I'm going to say network 10.1.101.11. Match it exactly. I'm going to say network 10.104.111. And then lastly, I'm going to say network 10.1.210.111. Match it exactly. Now hopefully we should get a peering relationship up and running. So far I'm not seeing anything. Show IP protocols. Well, let's see what we got going on here. So I've got 10.1.11 or 101. The one that I want to make sure I'm running is 210. So let's cut up to R2 and see what we got going on here. So do show run section router. And I'm not running it here. So what I'd do is I'd say network 10.1.210.2.0.0.0.0, and I should get my neighbor now, which I do. All right, so back over to, see, on cat 1. Let's go to R1 now and do the marrying config. So router do show IP interface brief E assigned. Don't want to involve any of these loopback yet. We'll be using these for the purposes of testing, but I do want to make certain that I enable all three of these. So in order to be able to do this efficiently, I'm going to say router EIGRP 10. I'm going to say network 172.16.1.1. Match it exactly. I'm going to say network 10.1.101. We'll say no, we'll do 201 first. Match it exactly. And lastly, we'll do 10.1.101.1. Match it exactly. Hopefully we should get a neighbor relationship with cat 1, which is going to be 11. So we see that that's up and operational. So now all I want to do is I'm going to go down to R4. Do show IP interface brief E assigned. And I'm going to run my loopback. And I am going to run my two fast Ethernet connections. So let's do these. So first of all, router EIGRP 10, network 172.16.4.4.0.0.0.0. I'm going to say network 10.1.45.4, match exactly, and I'm going to say network 10.1.104.4, match it exactly, and if I get my sums right, I should get a neighbor relationship with cat 1. which I can see because it ends in 11. I know that's Cat 1. So let's hop over to R5. Show IP interface brief, E, assigned addresses. And what we're looking at right here is going to be, we need to advertise the loopback. So let's go ahead and get that process started. Config T, router, EIGRP 10, network 172.16.5.5, match exactly. All right, now let's go ahead and advertise the loopback. So it's going to be network 10.1.205.5, match exactly, and network 10.1.45.5, match it exactly, and this should give me a peering relationship. So I'm going to update my drawing real quick. I've formed a relationship between 2 and Cat 1, between Cat 1 and R1, and between Cat 1 and R4. I have formed a relationship between R4 and R5. Now what I'm going to do is I'm going to go ahead and see if I can't close the loop by going up to R5. Let's see, I've already got the configuration for 205 here. Yes, I do. So what I'll do is I'll go to Cat 2. And on Cat 2, I'm going to configure it for my loopback and on my VLANs, my VLAN interfaces, my SVI. So do show IP interface brief E assigned, and what we're going to see here is these interfaces. So I want to actually have all of these participate in my protocol. So again, just for clarification's sake, router EIGRP 10, network 172.16.112.112.0000. We'll say network 10.1.201.12.0000. We will say network 10.1.205.12, match exactly. And then lastly, we will match on network 10.1.203.12.0000, match exact. And now what we hope to have is a full relationship formed between all of our different devices. Now let's look at this. Let's see what we have. So I've gone through and marked these as I went through and did my configs. But what I need to do is I need to verify these. So how do I do my verification? We will start on R2. And the way I'm going to do my verification is by typing the show IP EIGRP neighbors command. And in this situation, what I'm going to do is I'm going to highlight these in a different color to make sure that they've been verified. So on R2, we see that we are peered with a neighbor called 10.1.210.11. Well, that's going to be switch 1. We see that we are peered with 10.1.222.222. That's going to be R22. We see that we're peered with 10.1.23.3. That means I have a peering with R3. So let's cut over to R3 and do this same verification. Show IP EIGRP neighbors, and let's check it. So now I have two peerings here. So on R3, I have a peering with 10.1.232, which means I know I'm peered on 23 on the R2 connection, and I'm also peered with 10.1.223.22, which is going to be my connection to my R22 router that I have in my data center. But the problem is I do not have a peering relationship with SW2. So let's find out why. So first thing what I'm going to do is I'm going to do show CDP neighbors. And I can see I'm connected to Cat 2 on Ethernet 03, show IP or show run interface E03. Well, let's see, I've got 10.1.203.3. Let's take a look at my routing process. Show run section router. Well, I don't have 203 as a network command, so I need to modify that. So what I'll do is I'll just grab this very quickly, say config T, and I'm going to plug this bad bear in right here. So I'm going to say router EIGRP 10, network, plug it in, match it exactly, and I should get a link now appearing. So show IP EIGRP neighbors gives me a direct output that tells me I am connected to 12, which I know is Cat2. So quickly, I'm just going to go to R1, execute a verification, show IP EIGRP neighbors, and I should be connected or peered to Cat1 and Cat2. So I see Cat1 and Cat2. So these all check out. So next, what do we want to do? Next, what we need to do is verify that we have the connectivity on R4 and R5. So we'll start on R4. R4 should have connections to Cat1 and Cat5. Now I see Cat5, I'm sorry, R5 and Cat1. So they seem to be up, but I'll just redo it. I'll redo the verification. Show IP EIGRP neighbors. And as I can see, everything is up and connected, and notice that my Q counts are 0. So just based on that verification, I know that these links here are operational. So that only leaves me to verify R5, exit, show IP EIGRP neighbors, and I see that I'm connected with 12. So that tells me that every link that I have is up and operational, except for the connections that I'm going to be running to my configs on my remote sites, my 3 remote sites, R19, R20, and R21. We'll entertain those when we start looking at how EIGRP is deployed in environments where we have the idea of non-broadcast multi-access environments, because just like in RIP, what we're going to find is that we're going to have this idea of split horizon enabled. But we'll entertain that on the next video. But before we dive out of here and move into that, what I want to do is I want to highlight the fact that we have interconnectivity and do some verifications with regard to routing. Now I'm going to do those in the context of R22. So from R22, show IP route, EIGRP is going to give me prefixes that I've learned from my routing protocol. So I see I've learned 1, I've learned R2, R3, R4, and R5's loopback addresses. So let's do some verifications. I'm going to say ping 172.16.22, 33, 44, 55, 66, don't have a 66. So let's see, I don't have any connectivity. Let's verify using a loopback. So we'll say source it from my own loopback 0, and I have reachability. Now what I want to verify, show IP route for 172.16.1.1. I should have 2 prefixes, well 2 routes, and I do. I'm coming through serial 2.1 and serial 2.0. Just to verify, this should tell me that I'm going to load share. So if I do a trace route, and I do my trace route to 10 or 172.16.1.1, I'm going to see that I'm going to go through R2 and R3, through Cat2 and Cat1, and then all the way to my destination of R1. So this tells me that my infrastructure is up and running. I'm operating on EIGRP on every side to the left of our remote sites. So again, this is going to be important because what we're going to do is we're going to entertain how EIGRP behaves on a non-broadcast multicast environment in the next video. With that being said, I'll see you guys there. Bye-bye.